Okay, we're talking about inverses and one-to-one functions. So just some notation stuff really quick. If f of x equals y, then this with the -1, that means inverse. Okay, so this here is just a note. When you see f to the -1 power, it's an inverse notation. It does not mean to move f of x to the bottom of a fraction. Those are exponent properties, but that means inverse. Okay, so this is really big. Remember that x and y, I just crossed it out, switch places in an inverse function. So see how x is here in the parentheses equals y? When we have an inverse, y is in the parentheses and it equals x. Something else we're going to see in this section is if you substitute g of x into function f, you get x. And then the other way, if you substitute f of x into function g, you get x. So a function has an inverse if it passes the horizontal line test, and that is called being one-to-one. So remember, if a function is a function, it passes the vertical line test if you move a line along a graph. So now we're going to turn the line horizontally and move it up and down. If it never crosses 2 points at one time, then it passes the test. It's one-to-one. It has an inverse. All those three things go together. If it passes the test, it has an inverse, it's one-to-one. All right, and then the last thing, we're going to look at graphs of inverses. So the graph of an inverse, it's a reflection across the line y equals x. So let's look at an example really quick. We have a function 2x minus 1, and we want to find the inverse algebraically and then find the inverse graph. So we're going to sketch a graph. I'm actually going to take that out. We're going to do algebraic inverses in the next section. So let's just find the graph. So y equals 2x minus 1. Remember, this is mx plus b. You start at -1. And then I'm just going to make my graph a little bigger. Move myself. Okay, so we're going to start at -1 and then go up 2 over 1, up 2 over 1, up 2 over 1. And that continues, and we have a graph. So that graph is, if I could draw a straight line, f of x. Now we want to find the inverse. So I'm just going to show you on our xy for 2x minus 1. I'm going to go to Desmos and go to the table. These are my points. So -2, -5, -1, -3, 0, -1, 1, 1, 2, 3. So remember, on our inverse function, the x and y values switch. So now we're going to have -5, -2, -3, -1. See how I'm switching all my x, y's? So when I graph my inverse, these are going to be my new points. So back 5, down 2, back 3, down 1, back 1, nothing. It goes through 1, 1, and then over 3, up 2. So there's my inverse graph. And it's hard to see, but I'm going to just write the formula from this. Notice how I'm adding 1 every time. That's my slope. And then my intercept is a little hard to see. Maybe I won't have it. I'm just going to see. If you reflect over y equals x, that's how you get the inverse. So I can plot those points. I was hoping I was going to get the y-intercept so I could hurry and write a function, but that's okay. I got an x-intercept, and the y-intercept's probably right in the middle of those. I bet it's a half. I keep getting in the way, moving myself. So x plus 1/2. Oh, not quite. I was trying to get through those points. Aha! There we go. So there's my inverse function. It reflects over y equals x. That's the main thing I want you to know. And that the x and y values switch spots.